So before anything else, let me introduce to the topical workbook for computer science 2210 or 0478. This is the workbook 1 for paper 1, basically computer systems. And as you can see from the table of contents, I've included questions on each and every subtopic from the syllabus along with the mark scheme. And these are some of the actual questions, actual pages as a preview from the workbook. Section 1.1, 1.3, 2.2, 3.2, 5.3 cybersecurity and artificial intelligence. This is just to show you a glimpse of what type of questions are included in the workbook. There are many more questions where these come from, and around 18 to 20 questions on an average are included for each and every topic. A must buy if you want to boost your grade. Similar to the paper 1 workbook, I have designed a paper workbook for paper 2 as well. This is for algorithm, programming and logic for CAIEs either 2210 or 0478 GCE or IGCSE Computer Science. As you can see, it contains questions on every subsection of the syllabus content for paper 2 along with the mark scheme, so you can understand each and every question, each and every algorithm. These are some of the few pages from the workbook just to give you a glimpse of what type of questions are included. As you can see, this is 7.1, this is 7.7, 8.3 and section 10 Boolean logic. So a lot more questions are included in the workbook. A must buy if you want to have a very good score in your Cambridge examination. Order now. Assalamu alaikum warahmatullahi wabarakatuh. I hope you guys are doing fine. So we were discussing section 1, motion, forces and energy for physics 5054, and today we are going to start with section 1.2, that is motion, dynamics, or you can say kinematics, the physics of movement. So the first thing you need to know is what is distance and what is displacement. So distance is a scalar quantity that refers to how much ground an object has covered during its motion. Its SI unit is meter, and it is always positive and can never decrease with time. Whereas displacement is a vector quantity that refers to the shortest distance from position A to position B, or from initial position to final position. Its SI unit is also meters. It can be positive or negative depending upon initial position of an object. For example, a boy walks from point A to point B, then from B to C, and then from C to D, and then from D back to A again. What will be the total distance and what will be the total displacement? So for the total distance, we simply have to add on all of the available distances. This is 3, this is 5. Since this is a rectangular path, so this would also be 3. So 3 meters plus 5 meters plus 3 meters plus 5 meters, because this boy is going here, then here, then here, and then back here. So it would be 3 plus 5, 8 plus 3, 11 plus 5, 16 meters. Whereas the boy started from over here and then he got back over here. His final position is A and his initial position is also A. So A minus A would be 0. So his overall displacement is 0 because his position has not changed from his initial position. You need to keep this in mind, that if something returns to its initial position after a journey, its distance would be changed but its displacement would remain 0, or overall there would be no displacement. As you can see, A minus A would be 0 since this initial and final position is same. So we would say no displacement has taken place. What would be the distance and displacement if the boy walked from A to D? for A to D, the distance would be the from A till B 3 meters, B till C 5 meters, and C till D again 3 meters. So the total distance would be 11 meters. Whereas displacement is the shortest distance between 2 points. In this case, it would be the the horizontal distance between A and D. That would be 5 meters. The shortest straight line between A and D. An object moved from P to Q in the following path, covering a distance of 20 meters. Find distance and displacement. From P to Q, it is given that the distance took 20 meters. So our distance is given right in the question, that the guy traveled a total of 20 meters from P till Q, whereas the displacement would be the straight line between P and Q, which is given as 2 meters. The difference between the position of P and Q, that would be 2 meters only. Let's look at another problem. Sam starts from point X and moves towards east for 8 meters, reaches point Y and runs to his left, covering a distance of 6 meters to reach point Z. Find the displacement of Sam from X to Z. Now first of all, we'll draw a vector diagram for this so that it is easier for us to understand and solve. So first of all, the boy goes towards east for 8 meters, X to Y, and then from at Y he turns to his left, means in this position, anti-clockwise position, and then from Y till Z he covers a distance of 6 meters. Now the distance would be 8 plus 6, 14 meters, whereas the displacement would be the shortest straight line between point X and Z, the initial position and the final position. And for that we can draw a hypotenuse over here, and we can use the Pythagorean theorem to find the length of this hypotenuse, like this: xz square, this thing, equals to xy square, means base square, plus perpendicular square, that is yz square. So 8 square plus 6 square equals to 100 under root, and the xz would be 10 meters. So the displacement from X till Z would be 10 meters, whereas the distance would be 14 meters. Now if the guy was only walking from X till Y, then the distance and the displacement both have been same. Both of them would have been 8 meters. Next we have speed and velocity. Now speed is the distance traveled per unit time. It is also a scalar quantity with its SI unit as meter per second. That is basically taken from the formula: distance is meters, time is in seconds, so the unit of speed becomes meter per second. Equation for speed: the formula for calculating speed is distance upon time, or distance covered divided by time. Then we can also write it like V equals to S upon T. Equation for average speed: now there is a difference between speed and average speed. Average speed is for the whole journey, whereas speed can be calculated for any part of the journey. Average speed equals to total distance covered upon total time. Speed is usually measured using a speedometer. Now what is velocity? Velocity is the rate of change of displacement per unit time, means if you're plugging in the value of displacement for your calculation, you get velocity, whereas if you're only putting in the value distance, then you get speed. They both have the same SI unit, that is meter per second, and the equation for velocity is displacement upon time, whereas for average velocity it is total displacement upon total time. Velocity is vector, so you have to state both its magnitude and direction in order to describe it completely. For an object to have a constant velocity, it is needed for it to be moving in a straight line at a constant speed. On the other hand, speed can remain constant if direction is changed and magnitude is kept constant, as speed is a scalar quantity. If a car is turning around at 20 kilometers per hour, it is possible, but while it is turning, since the direction is changed, we cannot say its velocity is also 20 kilometers per hour. As long as a car is traveling in a straight line, we would say that okay, its velocity is 20 kilometers, but as soon as the direction changes, the car takes a sharp turn, we would say the speed is 20 kilometers per hour, but we will not be saying the velocity is 20 kilometers per hour. Velocity would be different, or at least it would not be constant. It would not be considered constant because the direction would have been changed. Now there are two things. One is known as instantaneous speed and the other is average speed. Instantaneous speed is the speed at any given time during the journey, and average speed is the average of all instantaneous speeds that is found simply by total distance upon total time. Now let's look at an example. A car travels 5 kilometers due east and makes a U-turn back to travel a further distance of 3 kilometers. The car completes the journey in 0.3 hours. Find the distance covered. So for finding the distance covered, we simply add on all the distances. So 5 kilometers plus 3 kilometers without paying any attention to the direction, we get 8 kilometers in total. The displacement of the car. Now the displacement is the difference between final position and initial position. The car traveled in a direction like this for 5 kilometers and then it took a U-turn and came back another 3 meters. This was 5 kilometers and this was 3 kilometers. Now over here, this is your initial position. This here is initial position and this here is your final position. So the difference between this point and this point, the shortest distance between these 2 points is a vertical one. This one. And how can we calculate it? Final position minus initial position. Or we can simply minus these two. So that would be, how much would it be? 5 minus 3, that would become 2 kilometers due east of the starting point. The average speed, total distance covered upon total time, that would be 8 kilometers divided by 0.3 hours, and it is going to give us 6.67 kilometers per hour. And the average, 26.7 kilometers per hour, whereas if you have to calculate the average velocity, we are going to use the value of displacement, that would be 2 kilometers. So 2 kilometers minus divided by 0.3 hours, that would give us 6.67 kilometers due east. Now another thing that you should know is displacement can be negative. So when you are going in this direction, it would means plus 5 kilometers, and when you're returning back in a parallel position in a opposite direction, then we would consider it as minus 3 kilometers. So 5 minus 3 would give you 2 kilometers, and that divided by the total time taken, 0.3 hours, would give you the value 6.67 kilometers, and the direction would be due east because this point is eastward from the initial position. Now that we have discussed speed and velocity, we need to know what is acceleration. Acceleration is simply the change in velocity per unit time. As it is calculated from velocity, so acceleration is also a vector quantity. Its unit is meter per second square, or meter ms raised to power minus 2, means meter second inverse is raised to the power of a square. Equation for calculating acceleration is a equals to v minus u upon t. This got a little messed up, so let me write it properly. This is the equation for acceleration. V is the final velocity, u is the initial velocity, and t is the time taken. V is okay. When velocity of an object increases, it accelerates, and when velocity of an object decreases, then we say that the object is decelerating or retarding, or it is having a negative acceleration. When direction of an object changes, its velocity also changes, hence it undergoes acceleration. As change in direction is equals to change in velocity, and that by definition becomes our acceleration. If the velocity of an object is constant, then the acceleration is considered as 0, because no change is taking place in terms of velocity. And if there is no change, then final velocity and initial would be giving us a value of 0, and 0 divided by time, whatever the value is, the value of time would also give our answer as 0. An object is said to be undergoing uniform acceleration when there is a constant change in velocity per unit time. For example, if a car is traveling westward at 30 meters per second and it suddenly comes to a halt in 5 seconds, find its average acceleration. So we'll apply the formula a equals to v minus u upon t, whereas the final velocity is 0 because the car comes to a halt. Initial velocity is 30, that is what the car was traveling with. So 0 minus 30 divided by the time taken, that is 5. So the acceleration would be minus 6 meters per second, and the minus symbol would be showing that the car is stopping or coming to a halt, or it is decelerating, and the direction would remain the same, towards the west. The negative sign shows the deceleration or the retardation. Now, according to your syllabus, you need to know and be able to explain a few examples of uniform acceleration. So here they are. When a body falls freely, then it accelerates uniformly with a magnitude of acceleration due to gravity. Hence, the velocity of the body increases by equal amounts in equal interval of time. And secondly, if a car is moving in a straight line without taking any turns with varying velocity, its acceleration would increase uniformly. And examples of non-uniform acceleration: the motion of a table fan when it is switched off till it stops can be referred to as an example of non-uniform motion, as the rotation of fan is not constant and it is changing with time. When second example, when an object is thrown upwards, its initial velocity is high, which keeps decreasing at a rate of 9.8 meters per second until it stops, and then comes down with an increasing velocity till it hits ground or reaches terminal velocity. So these two are the examples of non-uniform acceleration. Then we have some equations for motion. There are 4 equations in total. V equals to u plus at, means this is derived from the acceleration formula, this one. This t is taken over here, at, and this u's added over there, so it becomes v equals to u plus at. If in the question you're not given the distance but you're given initial velocity, final velocity, acceleration and time, then you can use this in order to calculate the values. Okay, but you need to remember that you can only use these equations if and only if your you can say your acceleration is constant. If your acceleration is not constant, then you cannot use any of these equations. Then for distance, you can use distance equals to ut plus half at square. That means even if you don't know the final velocity of an object, you can still calculate any of the other values. If you don't know the acceleration and the time taken, but you need to calculate the final or initial velocity or the distance, then you can use s equals to half u plus v into t, or s equals to u plus t half u plus v half t. If you do not know the time but you need to calculate either of s, u, v or a, means initial velocity, final velocity, acceleration or the distance, then you can use v square equals to u square plus 2as. Now all these equations consist of 4 values. If you are given any 3 in the question, then you can use that to calculate the 4th one by using this chart. Just remember these 4 equations. These would come really handy while solving questions, because the questions related to acceleration or distance are not always so simple as that you won't be able to utilize this formula everywhere. You are going to need to plug in one or more than one of these equations in your answer. Now if we are measuring speed in experiments where the value is really short, then we often use a device that is known as a ticker tape timer. A ticker tape timer looks something like this. It basically is a machine that produces a dot on a thin strip of paper at specific intervals of time. Usually 50 dots per second are produced by a ticker tape timer. The tape is attached to the object, and when the object moves, the tape is pulled and the dots are casted onto the paper strip, and the position or the not the position, the distance between those dots can tell the speed of the object. Given that the figure consists of 3 tapes x, y and z, which is over here, with a length of 1 meter from the first dot to the last, this is supposed to be 1 meters, 100 centimeters. The dots are made by a ticker timer with a time interval of 0.1 second. So that means that this ticker tape timer is making 10 dots per second. So in the x, what is happening? All the dots are equally spaced from each other. That means the speed is constant. You can also check it like this: 0.2, that is supposed to be the distance between one dot. As you know, from over here till over here it is 1 meter, and there are 1, 2, 3, 4, 5 dots. So 1 divided by 5 is 0.2. So distance upon time, 0.2 divided by 0.1 would give you 2 meters per second. For each dot, the distance is same, the time is same, so you can check that these dots display a constant speed. Just remember, in a ticker tape timer, whenever the dots are equally placed, it means that speed is constant. If the dots are closer to each other, then that means that there is the dots are closer to each other, means the speed was slow, but then gradually the dots are moving further apart from each other. This means the speed is increasing with time, whereas over here the dots have increased distance, but it is slowly decreasing by the end of the ticker tape timer or ticker tape. This indicates that the object or the whatever trolley or vehicle or toy car you're trying to experiment with is decelerating. And if in a ticker tape timer all the dots are made on at the same point, this indicates the object is at rest. Acceleration due to gravity. Neglecting air resistance, all objects experience the same gravitational acceleration of 10 meters per second square, or often it is taken as 9.8. It depends on whatever value the examiner gives you, where in physics paper you can use 9.8 or 10 interchangeably unless otherwise stated so explicitly by the examiner for a specific question. And every object is pulled down at the rate of 10 meters per second square by towards the center of the earth. This is known as the value for g, or the value for acceleration due to gravity. This is commonly referred to as downward in different questions. Constant acceleration of 10 meters per second square, or a gravitational acceleration, they both mean the same thing. This means that the speed of a downward falling object will experience or will increase by a rate of 10 meters per second until it reaches terminal velocity. It also means that the speed of an object going upwards, means if you throw something in the air, will increase by will experience a constant decrease of 10 meter per second. In general, the faster the object travels, the greater the air resistance. Now, when an object is moving in presence of air, then the object strikes against the surface of air molecules. This is known as air resistance. Just like we have seen in case of an object traveling upwards, we have enough air molecules in our atmosphere that if an object is traveling upwards, the air molecules bump against the surface of that object and slow it down at a rate of 10 meters per second. Like if you throw a ball upwards with a speed of 90 meters per second, then after 9 seconds the object would come to a stop, because after every second 10 meters per second would be its speed would be decreased by 10 meters per second. So after 9 seconds it would be at 0. The object would stop and then it would come down. When an object falls without neglecting air resistance, it experiences acceleration and increase in velocity. Like we have established, 9.8 or 10 meter per second increase in speed or velocity. This will cause air resistance to increase as well. There will be a point when the air resistance and the acceleration downward would become equal, or the weight of an object or the air resistance would become equal. This will cause the resultant force to become 0, because both upward and downward forces would be equal in magnitude but opposite in direction. So let's say plus 5 and minus 5 would become 0, plus 18 minus 18 would become 0. So there would be no net force, no net acceleration on the object. At that point we say that the object has reached terminal velocity, or a uniform velocity, or a constant velocity. This is usually referred to as terminal velocity in questions. The magnitude of gravitational acceleration is determined by the mass of the earth and not by the mass of the object, which means even if you drop a feather and a bowling ball in vacuum, they both would cover the same distance in same given time, if and only if you neglect air resistance, or you use a vacuum pump to create a vacuum, a place where there, or a tube where there is no air at all. If you're considering air resistance, then obviously an object with lighter mass is going to experience greater air resistance. Now let's look at an example. Figure 2.1 shows a skydiver falling vertically downwards at terminal velocity. Arrows X and Y show the two main forces acting on the diver. State the name of force X and force Y. X is downwards, so it should be the gravitational pull or the weight of the diver, whereas Y is upward, so it should be the air resistance. Explain why force Yx upward. Because air resistance always works against the direction of motion. If the diver is going down, air resistance would be working in upwards. If the diver is going up, the air resistance would be working downwards. If an object is moving to the left, the air resistance would be working towards the right. Always remember this point. Last but not the least, we have kinematic graphs, or the graphs of motion. So we have two types of graphs in your syllabus for O levels: distance time graph or displacement time graph, and the second one is speed time graph or velocity time graph. There is a third type of graph as well in kinematics, that is known as acceleration time graph, but it is not really a part of O-level syllabus, and it is rather included in the A-level physics syllabus. So for now, we are going to have a look at different types of speed time and distance time graph, because you need to know the shapes of the graph. Often you'll be given a graph and you'll be asked to explain a portion of it, or explain comment on different sections of a graph, that what is happening over there. So for that you need to know the shapes of these graphs very well. In a distance time graph, the gradient of the line is equal to the speed of an object. If you calculate the gradient of a distance time graph, you are going to get the value of speed for that object. The greater the gradient means the steeper the line, the faster the object is moving. So if you have a graph for constant or uniform speed or uniform velocity, it would look something like this: a diagonal straight line. And since the speed is constant, the overall acceleration would be 0. Graph for constant speed with steeper slope means high constant speed would look something like this, would go something like this, whereas if the graph looks like this, now this would mean slower speed, this would mean higher than this, and this would mean higher than this speed. The steeper the slope is, the higher the constant speed. The lower the slope is, the shallower the slope is. That means the closer the slope is to the x-axis, it means the slower the speed. Graph for an object at rest. If a distance time graph is having a flat line, a horizontal line, then that means that portion, for that amount of time in the graph, for that portion of the graph, the object was at rest. If we have a shape like this, so if you have a hyperbola like this, then that means the speed is increasing, but not at a uniform rate and not at a constant rate. The speed is increasing differently per unit time. And if you have a graph like this, a hyperbola, that means that the object is accelerating due to gravity. If you have something like this, well, this graph is wrong. Let me correct it quickly. Now all corrected. This is a graph for decreasing speed at a non-uniform rate. As you can see, not the same amount of distance is being covered per unit time. So it means that it is this graph is depicting non-constant speed. Whereas if an object is decelerating, means it is thrown upwards, and due to the effects of gravity it is decelerating, then the graph would look something like this. The distance being covered increases with time, but not at a constant rate. It comes to a halt and then it increases. Gradient at a point of a non-uniform distance time graph gives the instantaneous speed of an object. If you draw a tangent over here and find out the gradient at this point, then it would give you the speed of object at this point and not for the whole graph. And as you know very well from mathematics, gradient can be calculated as change upon y, change of y divided by change of x, y2 minus y1 upon x2 minus x1. Next we have speed time graphs or the velocity time graphs, and the area under a speed time graph means shows us the total distance covered, whereas the gradient of a velocity time graph gives you the value of acceleration. And if you have an object at rest, then the graph is going to look something like this, or you may have a straight line along the x-axis over here on top of the x-axis, that with the continuation of time the speed remains 0 because the object is not moving at all. If you have an object moving at a constant speed, then you are going to have a horizontal line like this that is parallel to the x-axis, not on top of the x-axis. Whereas a graph for an object traveling with uniform acceleration is going to look something like this. Again, if the graph is slanted over here, that means less acceleration. If the graph is steeper, that would mean higher acceleration. Graph for an object moving at non-uniform but increasing speed is going to look something like this parabola, whereas if an object is moving at non-uniform but decreasing speed, then the graph is going to look something like this. And if a graph is decelerating uniformly, it is going to be a straight downward line. And a graph for non-uniform but increasing deceleration is going to look something like this, something like a quadrant, 1/4 of a circle. And if an object that is traveling at non-uniform but decreasing deceleration, then the graph is going to look like this. As the time is increasing, the speed is non-uniformly decreasing. You need to remember all these shapes because you are going to be given a question where 2 or 3 of these shapes would be combined together as sections of a graph, and you'll be needing to either explain the journey in terms of time, speed or distance, or you'll be needing to calculate the distance from a given speed time graph. Common misconceptions: when you are trying to find the distance traveled, you simply multiply the value of x-axis and y-axis. This is a very grave mistake. This can only work if the velocity is constant, means if the shape of the graph is like this, only then you can multiply the value of x with y and get your distance. Otherwise you always have to go for area under the graph. You have to divide the area under the graph into different geometrical shapes: a triangle, a right angle triangle, a square, or a rectangle, and then you'll need to find the area for those shapes, and then you'll have to add them together. So simply always remember, no matter what, you have to find the area under the graph if you want an accurate answer. It is okay like this. this portion of a graph is a right angle triangle, so we are going to use the area of triangle formula. Half base into height. Base is 3, height is 4, so 4 into 3 is 12, divided by 2 or multiply by half would give you 6. Whereas this is a rectangle, from 3 till 8 it is 5, and the height would be 4. 5 4s would be 20, so 6 for this part, the yellow triangle, and 20 for the purple rectangle. 6 plus 20 would give you the 26, and we would say the distance traveled is 26 meters. Now over here, if the speed is given in kilometers per hour, then we would say this is 26 kilometers, but right now it is given in meter per second, so we have calculated the distance as meters. Whatever is the unit of distance over here would be the unit of distance over here in your answer. Time is always on the horizontal axis, means it is on the x-axis, but you need to be careful about what the scale being used is, as there are 60 seconds in 1 minute and 60 minutes in an hour, so we can have multiple varieties of scales for the x-axis. If you need to calculate speed or distance from a graph, you need to remember to convert time in seconds if you are calculating speed in meter per second. If you are calculating speed in kilometers per hour, then you need to convert whatever the value of time is on the x-axis into hours. Now let's solve an example question. This figure shows a simplified speed time graph for a train that travels between two stations. Describe the motion of the train. So from the graph we would say that for the first 20 minutes, see over here the scale is given in minutes, the speed of the train was 0. So we would say that for the first 20 minutes the train was at rest, then it started moving. The straight line shows a constant speed, with a constant speed of how much is it? 20 meters per second. The train was at rest for 20 minutes, then it moved at a constant speed of 20 meters per second for how much time? 20 minutes, 40 minutes, 45 minutes. This is 5 mark. 60, 65, 70, 75, 80. So this is the 5 mark. So for the next 45 minutes it traveled at a constant speed of 20 meters per second, and then it came to a rest for the next 5, 10, 15, 20, 25 minutes. This is how you explain a graph. As you can see, the train stays at rest for 20 minutes, then moves at a constant speed of 20 meters per second for another 45 minutes until it stops again for 20 minutes. This is how you can explain it. For 2 marks this much is enough. Calculate the distance traveled by the train between the two stations. So the distance traveled can be calculated by calculating the area under the graph. Now over here there is this line is at 0, so we are going to ignore this part and also this part, because over here the speed was 0, that means no distance was traveled. Whereas this square shape is what we are looking for. We have to find the distance traveled by finding the area under this curve or under this graph. So over here we need to know the values of length and width. So the height is 20 or the width is 20, whereas from here till here it is 45. But remember, our distance would be in meters, whereas this portion speed is in meter per second, whereas this time is given in minutes. So we need to convert this time into seconds. So if we have 45 minutes, then how we can convert it into seconds? Just multiply them with 60, and that gives us 2700 seconds. This would be our value of this. Multiply with the speed, that is 20. 54 1000 meters, or you can write them in you can divide it by 1000 and write the answer in kilometers. Distance equals to area under graph, so 45 multiplied by 20 multiplied by 60, so that this becomes converted in seconds, would give us 54,000 meters or 54 kilometers. So that's it. This is all you need to know about section 1.2, the motion dynamics or the motion. I hope you have understood. I've included examples and past paper questions so you can understand it fully, that how to tackle the questions. If you still have any problem, feel free to contact me through your comments below, and please do give comments so I know how the physics portion, how are the physics lecture going. Please do let me know your comments, and I'll see you guys in the next video with another lecture. Take care. Allah Hafiz.